For the graphing motion vernier lab, which we've been calling the acceleration lab, I wanted to just kind of give you a couple tips and hints as to what you should be writing about in your lab report. So for question number 1, describe the difference between the two lines made on your graph in steps 4 and 5. Explain why the lines are different. So you should go back to steps 4 and 5, right? That's important information here, and see which graph we're talking about. Also, if you're going to explain why the two lines are different, right, we can very easily see that one is higher than the other. But you want to talk about why one line is higher up than the other line. What does that mean? How did you get it to be higher and one to be lower than the other one? Are there any math principles that go behind why one line is higher than another, or are there any math principles that explains what it means that one line is higher than another? So just stating that one is higher than another, not enough. How will the graph change if you walk towards the motion detector rather than away from it? Explain why, test your answer. Obviously, if you didn't do this in lab, we can't do that right now, but we've tested this out with the graph interpretation packets that we were playing around with. So if you walk towards the motion detector, what happens to the line? And once again, make sure that you're talking about why. Why is that the case that the line does whatever it does? Number 3, what did you have to do to match the graph you were given in step 7? So go back and look at step 7, see what graph it's talking about. And then it says explain your method clearly. So if you're going to be explaining a method for how to create a graph, that sounds a lot like graph interpretation. So you should do the same kinds of things that we've been doing for the last week or so with the graph interpretation practice and giving very specific sets of instructions. So we'll skip down here. So number 4, describe the difference between the two lines on the graph made in steps 10 and 11. So go back to steps 10 and 11, see what they're talking about, and explain why the lines are different. Once again, we're explaining why, and we're explaining math, right? Not just that one line is higher up than another, but what did you do to get that line to be higher? Why is that the case? What math principles explain all of this, etc. What is the definition of velocity? How is it different from speed? So right there are 2 questions that you could answer. So this should be at least 2 or more sentences. I think that a good answer would be more towards about 4 sentences. That's what we should be shooting for, maybe 3. But we can give examples. We can talk about why velocity is different from speed, what that entails, etc. What did you have to do to match the graph you were given in step 13? So let's go back to step 13 and look at that. How well does your graph match the given graph? Make sure your method is clear. So this is a 2-part answer. 1, we're talking about the method. And if we're talking about the method for making a graph, we're talking about graph interpretation. So you want to be very specific. First do this, then do this, right? How well does your how well does your graph match the given graph? That's a confusing sentence. So when you're talking about if it matches, that's the second part to this question. So this is another one where it's relatively easy to write a significant amount for because there's 2 parts to this question. So how well does your graph match this thing up here? Well, if it matches it pretty well, talk about why. If it's different than this graph, also talk about why. What was the difficulty in getting your lines to match this graph? Like, why was it difficult to do that? Is it something wrong with the motion sensor? Is it something wrong with the method? You know, like what's going on here? What was making that so difficult? So number 7 is just a graph interpretation question, 2-part. If it's a position, if it's a velocity graph, there are no times down here on the x-axis, so you can just talk about segment 1, segment 2, segment 3. Okay. Number 8. How does the acceleration versus time graph differ from the other 2 graphs? So that's the other 2 graph on 33E, right? That's what we're talking about here. So that would be your position and that would be your velocity. So how does the acceleration graph differ from those 2? You can talk about how they look different, but also why are they different? What is different about acceleration from position and from velocity that makes that graph so much different and so much more variable? That would be a good word to use in your answer, talking about why the acceleration graph is kind of all over the place compared to position and velocity. Why is that the case? 9 and 10, you're going to be labeling things on different graphs. This is all within 33E. So on 33E, that graph that's got kind of 3, that's got the position, the velocity, and the acceleration, go to the velocity part of it and label the acceleration and deceleration. On 33E, go to the acceleration graph and label the acceleration and deceleration points of where that occurs. Number 11, what is acceleration and how is it different than velocity? So this one should be easy to write a full paragraph here because acceleration is confusing, right? Acceleration has a lot of points, or a lot of different parts, let's say. It's not just how quickly your rate of velocity changes, but there's a whole bunch of information in there that make acceleration so much different than position and velocity, which is kind of what question 8 here was starting to get at. So when you're talking about acceleration, talk about how it's different than velocity, talk about how it's different than a position graph, talk about examples, give some details here that show that you've learned some information about acceleration. All of this graphing lab is really practice for the test as well, right? They're very similar in that in each case we're analyzing a lot of, many different graphs here. So they work in conjunction. That's why we're doing this all at the same time. So this should be practice for your test, and all of those resources that we've used for the test, like the graphing interpretation packets and all that kind of stuff, can be used when you're answering the questions for this lab. So don't think of them as discrete, totally separate resources or ideas, but use them for each other, and you'll do better on both of them. So hope this was helpful.